Since the dawn of time, many safety organizations have been in search of the ultimate system for preventing electrical hazards. It turned out that a well-structured electrical design is enough to ensure both building safety and human safety. When designing electrical systems for laboratories, several key considerations ensure safety and functionality. Here are the three major considerations for creating a safe layout of electrical systems: clear marking, avoid overloading, and proper placement. Clear marking involves labeling all circuits and panels clearly. To avoid overloading, lab workers can distribute electrical loads evenly to prevent overheating and failures. Most importantly, they need to place outlets and switches in accessible and logical locations to reduce the need for excessive wiring. All these layouts can reduce the risk of electrical hazards such as short circuits, overheating, and accidental contact. Ensure that electrical panels and controls are easily accessible for maintenance and emergencies. However, there is something as important as setting the appropriate electrical layout. It involves proper grounding and bonding of electrical systems to avoid the risk of electrical hazards. This ensures that in case of a fault, the electrical current has a safe path to the ground, reducing the risk of electric shock and equipment damage. Meanwhile, proper bonding offers protection by ensuring that all metal parts of the system are at the same voltage level. Speaking of protection, some circuit protection devices add that extra layer of safety to laboratory workers. Take, for example, fuses protect circuits by breaking the circuit if the current exceeds a safe level. Then there are circuit breakers that automatically cut off electrical flow when they detect an overload or short circuit. Moreover, the ground fault circuit interrupters, or GFCIs, perform a similar function by detecting imbalances in electrical current and shutting off power to prevent electric shock. It's imperative that GFCI outlets be placed next to sinks and water basins for further protection. While all these circuit devices are important, the proper installation of lab equipment is the ultimate protection against electrical dangers. Here are the key steps every worker should take note of. Follow manufacturer instructions, use qualified professionals for installation, and check electrical requirements, ensuring that the electrical supply matches the requirements of the equipment. In the process of installing lab equipment, proper labeling of circuits can come in handy. Apart from solving identity issues, labeling can make maintenance and troubleshooting more efficient. Clear labels reduce the risk of accidental contact with live wires and help ensure that circuits are shut off correctly during repairs. This practice addresses a significant safety concern for lab workers, contributing to a safer and more organized work environment. Today, many laboratories have been subjected to a sudden power outage that affects their operation. As a result, UPS systems have been a crucial device for providing immediate backup power to protect sensitive equipment from power interruptions. In many cases, they help prevent equipment damage during short-term power outages. However, there is a long-term solution to power outage problems. In many laboratories, backup generators have been used to provide power during extended outages when the main power source is unavailable. They ensure that essential systems continue to operate during prolonged disruptions. Certainly, it's not expected for laboratory workers to handle electrical tasks. As a result, lockout-tagout procedures have been put in place to safeguard employees during equipment maintenance or servicing. These procedures ensure that equipment is properly de-energized and cannot be unexpectedly activated or restarted. Here are some general lockout-tagout procedures. Notify affected employees that maintenance or servicing is required on a machine or piece of equipment. Apply lockout or tagout devices to the energy isolating devices using assigned locks or tags. Disconnect the energy sources by deactivating the energy isolating devices, such as switches, valves, or circuit breakers. Shut down procedure using the normal stopping procedure, such as the stop button or the switch, and confirm that the equipment is disconnected from its energy sources. Moreover, OSHA has always been compliant about the critical role of personal protective equipment in safeguarding workers from electrical hazards. Proper use of PPE can massively reduce the risk of injury from electrical hazards, including electric shock, arc flashes, and burns. Here are the equipment needed for electrical safety: face shields, non-conductive safety glasses, arc-rated hoods, rubber insulating gloves, and leather EH-rated footwear. Generally, face shields protect the entire face from electrical arc flashes, molten metal, and flying debris during electrical work. Employers should always select face shields that are rated for arc flash protection according to industry standards such as ASTM or ANSI. Specifically, non-conductive safety glasses protect the eyes from electrical hazards, flying particles, and chemical splashes. Just like face shields, employers should also select safety glasses with non-conductive frames and lenses that meet ANSI Z87.1 standards for impact resistance. The arc-rated hoods protect the head, neck, and shoulders from high temperatures and electrical arcs. Similarly, employers should select hoods with an arc rating that matches or exceeds the expected level of electrical exposure, as specified by standards such as NFPA 70E. Most importantly, rubber insulating gloves are needed to protect the hands and arms from electric shock while working with live electrical circuits. The ideal rubber insulating gloves are usually rated for the voltage levels you'll be working with. Lastly, the leather EH rated is a footwear that provides protection against electrical hazards and helps prevent electrical shocks. As always, employers must select footwear that is certified as EH rated by ASTM or similar standards. To avoid being a victim of poor maintenance, regularly inspect all this equipment for cracks, scratches, or damage. Always store them in a clean, dry place when not in use. By properly using these PPE items, you can significantly reduce the risk of electrical injuries and ensure a safer working environment.